Okay, so let's talk about balancing equations and do a few examples. So first, from the word description, if it's given to you, sometimes just the skeletal equation will be given to you, and then you'll start with number 2. But first, if you have a word description, write out the equation. And the skeletal equation is what it's called when you write down basically your shorthand, but it's not balanced, and information like your states and other information like heat, if that's given, is not included in there. Okay, so your skeletal equation is just your unbalanced shorthand. Then you have to do number 2, which is to balance it. So the first thing you're going to do is do your count like we did previously. Count the total number of atoms of each element, both on your reactant side and on your product side. And what you'll do after that is start balancing them by adding the coefficients. And oftentimes the best way to do this is to go from your more complex compounds, balance those out first, all the way to your simplest compounds, or more likely your simplest atomic elements. Because like I said previously, you'll see that when you're looking at your simplest elements, oftentimes a change in that coefficient doesn't affect changing all the coefficients in your equation. So just be aware there is an order to it, but you can start from the simplest and go to the most complex. You should still be able to get a balanced equation. Now when you do, each time you put in your coefficient and check it, count it as you go along. So just check, re-update your counts just to make sure you're keeping track of everything. And at the very end, you'll see that all of their total number of atoms and the elements on the left-hand side on your reactant side should be the same as on the right-hand side. Also, make sure that you have the smallest set of whole numbers, that if you can divide everything by 2 for your coefficients, that you divide it by 2, because that's not your smallest whole number ratio. Alright, so you want to check for the smallest set of whole numbers, or a whole number ratio. Okay. And once you're balanced and you have your smallest whole number ratio, the last thing you're going to do, oh goodness, is number 4. And that is, you're going to add your states, okay, and any other given information. Okay, so let's give it a try. So if I said something like, let's try liquid acetone, acetone burns in oxygen. That's, by the way, C3H6O, burns in oxygen to form carbon dioxide and water. Okay, so when we look at this word equation, first we need to write the skeletal equation. So the skeletal equation you're just going to put it down in that shorthand. So, liquid acetone. Okay. Plus an oxygen. Now, we're not talking about oxygen atoms. So remember the context. Remember, oxygen in the air is not O. It's O2. It's one of the diatomic molecular elements. So remember the 7, the Bringelhoff, or I have no fear of ice cold beer. Oxygen's in there. So we're going to write O2. Okay, so that's why it's so important for you to be able to memorize those 7 diatomic molecular elements because they're used so often. Okay, and so you understand the context. Carbon dioxide, since we know our nomenclature and you're pretty familiar with carbon dioxide, CO2, and water. Okay, I want to give some space here. Okay, so now that we have our skeletal equation, now we need to balance it. Okay, so we're going to go ahead and balance the equation. So step 2, balance the equation. Okay, so what we're going to do is we're going to do a count. Carbon, hydrogen, and oxygen. I have 3 carbons, 6 hydrogens, and I have 1 plus 2. I have 3 oxygens. Now the carbons, hydrogens, and oxygens on the product side, I only have 1 carbon, 1, 2, 3 oxygens, and 2 hydrogens. Okay, so it's pretty clear we're going to want to balance out our carbons and hydrogens first, and then we'll go back to oxygen, because right now oxygen looks good, but who knows after we're done. Okay, so let's do carbon first. If I have 3 carbons here, then in order to get 3 carbons, I need to have 3 as my coefficient. That means I have 3 carbons and I have 6 oxygens. So I have 3 carbons. So notice how we're recounting everything. I have 6, 7 oxygens. Okay, but remember how we go from the more complex to the simplest? Well, O2 is simpler than H2O. So let's take a look here. I have 6 hydrogens, 2 hydrogens there. So let's go ahead and multiply this by 3. 3 times 2 gives me 6. 3 times 1 is 3 plus 6. That gives me 9. Okay, so my carbons are good, my hydrogens are good. Now I have 9 oxygens here, but 3 on this side. So what do? So let's take a look. On this side, I don't want to touch this oxygen because look at my carbons and hydrogens are good. So I have 1 oxygen, and then here we haven't done anything with, plus 2 oxygens. Okay, that gives me my 3. I have 9 here. So if I keep this 1, then I need 8 more to get 9. So if I keep, this is an O, 1 plus 2. Okay, if I keep this one, then I actually need 8 more to get 9. So what times 2 is going to be equal to 8? So I'm going to put a 4 right there. So now we see I have 4 times 2, that gives me 8. And then since I didn't want to touch this coefficient, I have 1. So now I have a total of 9 here. So just so you know, how did we get 9 there? I had 3 times 2, that gave me 6 oxygens. And 3 plus times 1 is 3 oxygens. And then I added it together to get 9. So now everything is balanced. Okay? So what you want to do is you can just go through and just double check. Okay? Three carbons, 3 carbons. 6 hydrogens, 3 times 2 is 6 hydrogens. 1 plus 8 is 9 oxygens. 3 times 2 is 6. 3 times 1 is 3. So 6 plus 3, 9 oxygens. So it's balanced. Okay? So now we have to add any additional information. So now we're looking at states, number 4. So the problem here tells you it's liquid. Acetone's a liquid. So you put an L here. Okay? It burns in oxygen. Well, we're breathing oxygen actively right now. We know it's a gas. Okay? What about carbon dioxide? It's not specified, but you know carbon dioxide's a gas. And if we refer to H2O as water, we know that's going to be a liquid. Okay? And that's all. There, I can't add heat because it doesn't tell me I needed to add heat. So you can only put in the information that you're given. And in this case, and that we automatically know that some of the states like carbon dioxide, water, and oxygen, those are assumed you know. So basically, this is how you balance your chemical reaction